morning from Sri Lanka. There's an announcement to our those who are gathered here at the moment. There will be around 6 to 7 minutes delay in starting this event. So we would like to invite you to bear that and please remain with us. Thank you.
Hello, NSF Sri Lanka. So I'm Professor Yan Song Wei. So NSFC and the staff and others project PI, because this is lunchtime for in China. So we arrange a simple lunch for them, and they will come back in the meeting room. Okay, so waiting minutes. Waiting minutes. Thanks. I will tell them. So NSFC, yeah.
Dear colleagues from Sri Lanka, can you hear me now? We shall start the meeting in 1 minute.
Yes, we can hear.
Yes. Dear colleagues and dear leadership, those from NSF and NSFC, and especially dear PIs of the NSFC and NSF, the first joint research program, both from Sri Lanka and China. And it's great pleasure to hold this meeting. And my name is Nianhe Rong. I'm working as the contact point for the NSFC and the NSF Corporation. And it's my great pleasure to speak here. And before we start meeting, shall we suggest for all the participants, for all of us, turn on the camera and we shall take a group photo first.
Sri Lankan colleagues, all please on your video, we will going to take a screenshot. Please on your camera.
So we have still several persons, but many of them is from China side. So I think we will take a photo first and we shall start our meeting. So please, I shall count to 3, 2, 1, and everybody smile, please. 3, 2, 1, smile. Okay, thank you very much. So according to the program, we shall first invite the Director General of National Science Foundation of Sri Lanka, Dr. Saprika Singho, to give the welcome remarks. Please, Director General.
Madam, you are muted.
Ma'am, sorry to interrupt, it's still muted. Could you please turn on the microphone?
Right. So good
Okay, we can hear you now.
Good morning and greetings from Sri Lanka. Professor Zhang Yonto, Acting Director General, Bureau of International Cooperation, NSFC, and the senior officials, delegates from Sri Lanka currently in China, Dr. Shansiri, Additional Director covering duties NSF and the NSF team, provincial principal investigators of the 4 collaborative research projects and their research team members. Ladies and gentlemen, it's my great pleasure to welcome you to the joint event on the disseminating research findings of the NSF-NSFC, the first joint research program, to disseminate the key results, outputs, and the potential impact of the China and Sri Lanka. Dear colleagues, China has a long history of relations with Sri Lanka, and that take back to the 4th century AD when the Chinese monk visited Sri Lanka. Sri Lanka's relationship with China have therefore evolved through Buddhism, trade and aid, to more strategic ties based on infrastructure development and global connectivity. As such, China has been and will be a partner in Sri Lanka's economic development, as well as a dependable friend to Sri Lanka on the global stage. Dear colleagues, scientific solutions will come from working collaboratively across disciplines and by co-creating knowledge across borders through inclusive models that can fully understand and reach local contexts. So therefore, collaborative research has become more prevalent globally over the past years, and researchers are increasingly required to work across disciplines, institutions, and borders for success. Dissemination of research findings is also an important part of the research process, very important. And because passing on the benefits to other researchers, professionals, practitioners, and the wider community to strengthen evidence-based policymaking practices, which is a very important concept today. It is a strategic and deliberate method of applying empirical knowledge and research support principles to justice system decisions made at the cases, agency, and system level. So, dear colleagues, we are very grateful to have the researchers today to enrich the discussions. We also would like to thank the organizing committee for their extraordinary effort that brought us to be able to meet virtually. Very important. So, dear friends, by working together to share ideas, we can give substance to our commitment to leave no one behind. We do hope you find this event fruitful for your future career, for the sake of knowledge, and also on top of that, for the benefit of the humankind. Thank you very much.
Thank you very much, Dr. Scarico, for your kind rewards and the suggestion. And next, let's welcome Professor Zhang Yongtao, Acting Director General from the Bureau of International Cooperation, NSFC, to give the welcome and the opening remarks. Dr. Zhang, please.
Okay, thank you. Thank you, Mr. Rong. Dear Dr. Sapalika Sudarsinha, it's difficult for me to pronounce. Director General of the National Science Foundation for Sri Lanka. And distinguished professors, ladies and gentlemen, good morning. It's my pleasure to attend this called joint event disseminating research fundings, the NSFC and NSF first joint research program. So on behalf of the National Natural Science Foundation of China, I would like to extend my sincere congratulations to the successful opening of this meeting and a warm welcome to all the participants present here today and also online in Sri Lanka. So as we know, today's world is witnessing unprecedented global challenges, and human society is facing unprecedented common challenges. As one of the main founders of basic research in China, National Natural Science Foundation of China had always adhered to the principles of facing the world's scientific frontiers, economic development, major national demands, and people's welfare and health, and also attached great importance to and made forward-looking and systematic investment on research of global challenges. In terms of international cooperation, NSFC has initiated an international program with global research funders and international scientific organizations, and the theme of the human environment system dynamics and the UN's SDGs. NSFC and NSF has signed the MOU in 2016. Since then, we have established the successful collaborations on tackling the scientific questions of the chronic kidney diseases due to unknown etiology called CKDU. So we co-organized the China Sri Lanka Symposium on Climate Change Adaptation, Environment and Health in Beijing in the summer of the 2017. And after that, we co-founded 4 projects to tackle this urgent issue of CKDU in Sri Lanka. So I believe this joint event on disseminating research fundings of the funded 4 projects will not only provide a platform for Chinese and Sri Lankan PIs to discuss their research fundings and further strengthen the cooperation network among them, but also stimulate the interdisciplinary integration of health science, chemistry sciences, and earth sciences in relevant fields of both countries. Although the cooperation between NSFC and NSF has been influenced by the pandemic, we would like to reaffirm that NSFC is willing to continue and strengthen our cooperations with NSF in the area of CKDU and all the other global challenges faced by our 2 countries, and the joint cooperation framework between NSFC and NSF. So finally, once again, I would like to thank all scientists and colleagues present here today. I would also express my gratitude to the Research Center for Eco-Environmental Science, Chinese Academy of Sciences, for your thoughtful and warm arrangements for the great event. So thank you very much. The Deputy Director, Professor Yang Ming, also present here. So I want to thank the center again. Also for the projects, ongoing projects for the PIs, I want to thank the hard working for the research. I also hope to conduct more, productive results from the joint research cooperations. So at last, I wish the meetings a great success. Thank you very much.
Thank you very much, Professor Zhang, for your warm words about and emphasis on not only the importance of the NSFC and the NSF cooperation, but also for all the hard work of this PIs and the team of the NSFC and the NSF first joint research program. And according to the agenda, next session, we will welcome Dr. Li Wenzong, Director of Division of Asia, Africa, and the International Organizations, BIAC of NSFC, to give the brief introduction about NSFC and the NSF cooperation, as well as this this research program. Let's welcome Dr. Li Wenzong. Okay. Yes, we will share the screen now.
Thank you. Thank you, colleagues and friends. Good morning. We are now sharing the slides. I hope you can see it from online. It may take a few more seconds.
So dear colleagues online, can you see our shared screen now? It's about the
Yes.
first slide of yes.
Okay,
Thank
thank you. I'm very happy to join you in the meeting today and especially to see so many colleagues and experts from Sri Lanka. Welcome. And let's have a review of our collaboration and this program. The collaboration between NSFC and NSF Sri Lanka starts from 2016. And in that year, we had mutual visits of our leadership. And then we signed the MOU as the presence of our Premier Li Keqiang. In the 2017, NSFC organized a international workshop on founding science and people cooperation for a prosperous Belt and Road. In that meeting, we had guests from Sri Lanka, and it was a strong support from NSF because our Sri Lanka friend also joined us as a press briefing meeting. You can see the picture from the screen. That's the start of our cooperation, and very soon the two sides organized a bilateral workshop at the same place on climate change adaptation, environment, and health. During that meeting, we, through discussion, we jointly decided the direction and priority areas of our cooperation. Very soon, we released this call for proposal. It focused on the chronic kidney diseases and the reason for this disease is not clear. So we choose this health problem as a priority areas of our joint call. We found 4 projects. That's why we are organizing today's meeting. Here is a list of the projects we jointly founded. So today we meet here and also online to share the progress, especially the experience we gained through the cooperation. In 2019, one of our vice president, Mr. George Gao, who is very famous, also visited NSF. So for today's meeting, we hope the presenters can introduce your research from, for example, the 4 aspects. You could address each of the aspects with different emphasis. The first one is how did you organize the networking? Of course, because of the COVID-19, maybe much of the communication was conducted through online meetings or through emails. That's also one important aspect of our cooperation. The second aspect is the talent fostering, because we always hope the cooperation can benefit the young generation of researchers. And the third aspect, of course, is progress of your research. What did you find through the cooperation? And the last one is the dissemination and application of your findings. Last one but not least, I just want to reassure that NSFC attaches great importance to the SDGs and the underlying scientific problem. We have invested quite a lot of our funding to SDG related cooperation. So in the future, we will continue this commitment, and we hope with NSF Sri Lanka, we can have some further cooperation under this topic. and to strengthen our partnership. Thank you.
Thank you very much, Dr. Li Wenzong, for your very brief but very informative introduction and the review of this joint research program. And I think it's serving as a very good basis for the coming presentation and the review by our PIs from our both countries. So according to the agenda, we'll go to the main topic of this joint event on disseminating research findings. And we have 4 group of PIs. And according to the agenda, we'll first invite the PIs of the project entitled Enrichment Mechanism, CKDU's risk factors in groundwaters and their uptake pathways and potential remedies. And we will have the Sri Lanka PI first to give the 10-minute presentation. And let's welcome. Thank you.
Thank you very much. Very good morning to all of you. I will directly move into the presentation. So this is a very gender balanced team we have. We have 4 women investigators from Sri Lanka and 4 men investigators or male investigators from China to keep up the science diplomacy. Professor Dhammika is working on the cyanotoxins, plus Dr. Rasika from Sri Lanka. They are looking at the cyanotoxin interactions, where myself and Dr. Anushka Pamari Rajapaksha, we are looking at the remedial actions as well as the water chemistry. We are supported by eminent panel of scientists from China University of Geosciences under Professor Homing Guo. They have the team of Chumbo Hao and Dr. Wei Wu Siu. They all are supporting this project continuously, even though we were struggling with the COVID issues. So this is the total funds received from the National Science Foundation of Sri Lanka. And we have almost finished whatever the received amount, but this was not the actually requested amount for the project. It's quite less, the amount is less. So the objectives of the project are to quantify the amount of nephrotoxins, namely, especially we are focusing on the Hofmeister ions based with the basis of fluoride and other electrolytes plus cyanotoxins. So our main focus is given to these chemicals in the water and whatever the food these CKDU endemic and non-endemic areas are consuming. So we are looking at the interactions of potential nephrotoxins, the ones that we discussed earlier. And we look at the mechanisms of leaching of these nephrotoxins. Our main focus here is fluoride, how they are leaching from the rocks to groundwater, and then we are looking at the uptake pathways of fluoride, other electrolytes and cyanotoxins into biomolecules through plants and so on. Then we look at producing biopolymer composite to be used as a water treatment material, specifically to remove fluoride, electrolytes and cyanotoxins for the household use of these areas. We are very happy to say that we have completed objective 1 and 4. where we are, lagging a little bit on objective 2 and 3. We have very strong support from the Chinese collaborators, specifically for the borehole drilling. The work was totally funded by the Chinese collaborators. We have done 2 boreholes in Girandra Kotte, where we call it as CKDU endemic areas, and Sevanagala as CKDU non-endemic area. So these 2 boreholes, borehole logging materials, we have sent it to Chinese collaborators, and they are under analysis right now. At the same time, we have collected 2 sets of water samples, one set for our own analysis, and the next set for the Chinese collaborators for their analysis, because they do quite a lot of analysis and advanced analysis than us. So those 2 sets we used specifically to understand or compare the data between us, so that we know our instruments are also working okay according to the Chinese instruments, like the laboratory, 2 laboratory equipments types, specifically for the water quality analysis. Then we conducted manuscript preparation together. So we have published many articles collaboratively. So this is the strength of our collaboration between China and Sri Lanka in this particular project. Moving into output and impact of the research, I will just discuss about the Sri Lankan data set. Professor Guo will discuss about their findings mainly. So majority of the samples from CKDU endemic areas we saw that it is dominated by the rock-water interaction processes, indicating the influence of geogenic processes, specifically silicate weathering. So silicate weathering impacts the groundwater quality of the CKDU endemic areas as well as the non-endemic areas. Then water quality index, we have prepared a water quality index. We saw there are excellent good water quality in both CKDU non-endemic areas and endemic areas, but majority of the CKDU endemic areas are prone to having bad water quality or deteriorated water quality. Poor and unsuitable water percentage is higher, specifically in Girandra Kotte CKDU endemic samples than Dehiatakande, which are like very close by adjacent areas. But Girandra Kotte water is more or less poor and unsuitable for drinking. The stable isotope data indicated that CKD, the Girandra Kotte region is having surface water recharge input, having less surface water recharge input than CKD endemic areas. If you move into the social demographic information about these 2 areas, focusing on CKDU areas, the male farmers are the majority of affected people, and they are a little older than the female farmers or female population of CKDU. The main drinking water sources were well water, subsurface well water mainly. Previously, they are saying that they have been consuming agricultural well waters, before the disease was diagnosed, but they are not doing it now. So if you compare the percentages, male population is about close to like 45%, whereas female population is under 30% in CKDU, if you consider the gender equality. Considering the output of the water chemistry, average fluoride in CKDU endemic areas is higher than the CKD non-endemic areas. So Sevanagala samples are giving less fluoride levels than the Girandrakota samples. The variation is different in the Dehatakande region though. So we suppose that the acidic nature, like 6.5, around 6.5 pH in Girandrakota water can be resulting biotite and feldspar dissolution. Maybe with the interactions between the surface and groundwater. Pyroxene and amphibole may affect the alkaline nature of the Dehatakande and Sevanagala waters. So the statistical analysis showed there's no significant difference between alkalinity and total hardness. But CKDU endemic and CKD samples showed a significant difference, fluoride, and no difference between pH, alkalinity, and total hardness. But you clearly see significant difference between pH, total dissolved solids, fluoride, potassium specifically, and calcium. So potassium we have not been considered previously, but in this case we were looking it at as a we were thinking of looking at the electrolytes or the Hofmeister science as in total. The rock mineral characterization, there are not big difference, but still you can clearly see the ferrous and manganese oxide bound and organic matter bound fluoride is high in CKDU endemic areas, where the water bound, the exchangeable fraction is less. Comparing to cyanobacterial or cyanotoxins, we clearly saw that despite the sampling locations, microcystine, cylindrospomopsin, and nodularin producing bacterial species were identified in culture. And tubers, specifically the reservoirs, community wells, and irrigation wells reported much higher concentrations of microcystines compared to wells in both CKDU endemic and non-endemic areas. So that is something that we are concerned. Despite the location, the mean concentrations of microcystines in well water exceeded the WHO recommended levels, but we didn't see nodularin in these waters. Considering cyanotoxin, because cylindrospomopsin is very important to be looked at because of its toxicological nature for the kidney. So the mean cylindrospomopsin concentration of CKDU individuals' well water samples were significantly higher than non-healthy people in the these areas. Mean concentrations of cylindrospomopsin in well water samples from CKDU endemic and non-endemic areas did not exceed the WHO recommended levels, but we don't know the interactions, how it goes with the other organic biomolecules. So we need to look into this. The mean concentrations of we actually looked at the samples, rice samples vegetable samples collected from CKDU endemic and non-endemic areas, because there was no studies carried out with regard to this, the food and beverage intake, how these food and beverage intake affect the cyanotoxins as well as the nephrotoxins, like hofmeysteins. So we collected rice, vegetable samples and tea samples, because they use a lot of different loose tea samples, and they drink quite a lot of tea as a habit when they specifically in the farmlands. So this is the very first study. We are reporting that the cyanotoxins in rice, specifically with regard to the CKDU endemic and non-endemic areas, comparing both these two areas. So we saw that rice samples collected from CKDU endemic areas were having significantly higher microcystin levels. At the same time, the significantly higher fluoride, chloride, sodium levels were observed in raw rice samples as well as in tea samples. You saw a lot of potassium plus fluoride levels. So when you consider the overall uptake, the fluoride intake is quite high. Moving into the cyanotoxin and nephrotoxin removal study, we have come up with a composite which we observed the removal of both cyanotoxins, hardness, fluoride altogether simultaneously. So simultaneous removal studies are very rare, specifically when it comes to the cyanotoxins. We have actually documented a patent in Sri Lanka. The patent application is already done. So we hope the patent will be received soon. As the outcome of research, we have published about 9 articles in very in high impact journals with both sides, with the support of the collaborative efforts. 3 book chapters and many conference abstracts. There are 3 manuscripts in preparation, 2 research articles and 1 review article. So the recommendations and lessons learned from this work is the presence of fluoride, hardness, silica and electrolytes in groundwater at higher levels. We found them in high levels, but it might not be the only cause of for CKDU. Their interactions have not been studied. So it is very important suggestion that we are making here, the inclusion of biochemical efforts and ion solvation effects associated with these risk factors, specifically for protein denaturing in the kidney, are required for a better understanding of the nephrotoxicity. Otherwise, you can't clearly say how these, the presence of high concentrations of these different types of nephrotoxins may create the nephrotoxicity. We observe the overall intake of fluoride is very high when you consider water intake, food intake, and the beverage intake, like tea from the tea. So water, food, beverages, all 3 should be taken together to see the risks and the exposure for these nephrotoxins all together. So we always work on one aspect, but we need to work on the overall aspect of the exposure. That is very important. Complete removal of cyanotoxins from drinking water still remains as a concern in worldwide. So it is very important for us to look into the cyanotoxin removal in drinking water sources, that has not been given as a priority in Sri Lanka at all. With regard to the removal, scale up of the columns is important to be used in the commercial level, specifically for the households. Additional analysis we are recommending for the dissolution of sediments rocks to understand their release and specifically how they are taken up by the plants and the overall exposure risk. We have calculated the exposure risk from the rice, exposure risk from tea and water, but there has not been discussions to calculate the overall exposure risk. So I'm stressing here that overall exposure risk plus the nephrotoxicity as a chemical cocktail, like these chemicals are as a cocktail in the environment. So there's no point of looking at it separately. So we need to look at them collectively. That's all for the time being. Thank you very much for giving me the opportunity and the time. Thank you.
Thank you very much, Professor Masika, for your very informative review, and especially about the very fruitful results and output and the impact of your study. And as a person graduated from the medical school and the medical background, and especially have very great impression about your analysis and recommendation about the interaction of the chemical in cocktail, especially in your slide 7, figure 5 of the drinking water source of CKDU individual. I think it's very important finding for your research. And as a suggestion for the following researchers, may I suggest to control and maintain your presentation in 10 minutes so that we can have a full Q&A and discussion session afterwards. And next, shall we invite the Chinese partner, Professor Guo Huaming, for the introduction and the review from the Chinese group side. Thank you.
Can you hear me? Or any people in the online? I'm very glad to give a talk on the progress of our joint project. Just now, our Sri Lankan partner gave a brief talk on this project, and now I will give another talk from the perspective of groundwater fluoride, groundwater silica, and groundwater DON. And in this project, we have 4 Chinese investigators and also have 4 Sri Lankan investigators. And our Sri Lankan principal investigator is Professor Masika Vatinage. I will give this talk from this 6th part. One is introduction. The CKD means chronic kidney diseases of unknown Ethiopia. So this is prevalent in arid area of some tropical developing country, especially in Japan, India, Sri Lanka, Egypt, and some Balkan countries, Brazil and Mexico. This disease is especially important in Sri Lanka, which has threatened the people's health. And there's possible theological assumptions, including groundwater chemicals and also some including inorganic and organic component. About inorganic component, many studies show that fluoride, total dissolved solid, hardness, and also the dissolved organic matter and cyanotoxin, mycotoxin, also included in this hypothesis. And previous investigation showed that the CKDU-related groundwater normally had higher fluoride concentration and high hardness, high ratio of calcium to sodium, and also higher dissolved organic carbon. And the dissolved organic matter research also found that the groundwater, CKDU groundwater have abundant refractory organic substances. Mainly those substances mainly have the molecular weight of 900 to 1,800 Dalton. But there is still a controversy on pathogenic elements in groundwater, especially the enrichment progress of these CKDU factors are still unknown. And the second is molecular characteristics of the dome in CKDU groundwater are still not understood. This study shows that for the seasonal variation, the CKDU induced factor relatively high and lower in wet season, but DOC higher in dry season, and also the fluorescence peak shift to the lower wavelength. And we have also don't know this understand issue also occurred on seasonal variation in CKDU factors about especially in organic and inorganic component. Therefore, the objective of the project is to quantify the amount of norphotoxin and mainly fluoride, electrolyte, and cyanotoxin in groundwater samples collected from CKDU endemic area, and to understand the interaction of potential CKDU factors in groundwater, and also to assess the mechanism of relation of fluoride, electrolyte, and cyanotoxin, and accumulating to biomolecules. And finally, to produce novel biochar adsorbents as a possible remedy for those CKDU factors for household uses. And for Chinese side, mainly focus on fluoride, silica, and dome in groundwater. Sri Lanka side mainly on electrolytes and cyanotoxins. So I will mainly focus on this fluoride, silica, and dome. For the study area, we chose two typical areas. One is CKDU area in this site, and the other is non-CKDU area in the southeast side of the country. So those two areas is covered by Precambrian metamorphic rocks or granite. So the geological background is quite similar. This area is mainly what the year one the dry season and wet season. The dry season is mainly from March to August. The wet season is from the September to March in the next year. So we have collected 155 water samples, including 65 samples from CKDU area and 76 samples from non-CKDU area. We also collect some second water samples. We also drilled two boreholes in the two area. And we collect 60 sediment samples. Half of them were transported to Beijing for geochemical analysis in March of this year. The other half will be shipped in this September because of in the summer holiday we cannot deliver the money to the Sri Lanka partner. We analyzed the groundwater samples and sediment samples for inorganic and organic component. This is the result. We compare the chemicals, especially the pH, ORP, bicarbonate, silica, fluoride, and chloride between CKDU area and the non-CKDU area. We can find that the silica and the fluoride are much higher in CKDU area and then the non-CKDU area. But the pH and the ORP were significantly lower in CKDU area than a non-CKDU area. And we also collect previously published data of fluoride and silicate in Sri Lanka. And we found that the samples in this zone, 100% of samples is located in CKDU area. In this region, about 86% of samples is located in CKDU area. So that means that the great concentration of silica and the fluoride in groundwater, the larger proportion of CKDU groundwater. How those CKDU factors are reaching into groundwater, and we make some analysis on geochemical process of those silica and fluoride in groundwater, and it shows that the silicate weathering is predominant processes in those groundwater. And if we use the sodium asterisks, it means sodium minus chloride. This is indicate of silicate weathering. As show that these factors show positive correlation with fluoride and also silicate. This means weathering of fluoride-bearing silicate mineral control concentration of CKDU factors, especially silicate and the fluoride. In addition to silicate weathering, we also observe the potential of fluoride dissolution of those minerals in the aquifer because of the saturation of fluoride in groundwater system. In addition, the calcium cation exchange also occurred in the aquifer. And we also compare the result between dry season and wet season. And normally, in both these seasons, the CKDU area have relatively higher concentration of silica and fluoride. And also in dry season, the CKDU groundwater have higher silica and fluoride than wet season. So we plot the water isotopes in this figure. It shows that in wet season, the groundwater mainly recharged by salted water or meteoric water. But in dry season, in addition to recharge of salted water, evaporation also influences the groundwater chemistry. And this figure shows that the evaporation potentially enriched or increase the concentration of chloride and water chemistry in CKDU groundwater. Concerning the dome or groundwater dome in CKDU groundwater and non-CKDU groundwater, and we calculate the humidification index, fluorescence index, and the biological index, and we find that the DOC content in CKDU groundwater is significantly higher than non-CKDU groundwater. And also for this HIX, but for FI and BIX, those values were lower in CKDU groundwater than non-CKDU groundwater. So it means that the dome in CKDU groundwater has a high humic degree, but less biological degrees. And we also use the fluorescence spectroscopy to characterize the fluorescence components in those water samples. And we, by using of paraffin analysis, we get 4 fluorescence component in those water samples, including C1, C2, C3, and C4. For former 3 components, those they are humic-like compound, but for last one is protein-like compound. And this figure shows that humic-like compound dominate UM groundwater, but for CKDU groundwater, the C1 is much higher than non-CKDU groundwater. But for the C4, this component in CKDU groundwater is lower, much lower than the non-CKDU groundwater. So this is also support that the CKDU groundwater have higher humidification degree, but lower bioavailability. So this is molecular characteristics of DOM. The result also support the fluorescence characteristics. So we can find that the CKDU groundwater have lower aliphatics content, but a little bit higher the aromaticity degree, And this last figures shows that there's good collaboration between fluoride and these two this ratio, and between silica and this ratio. So this also means that the CKD groundwater have higher aromaticity degree and lower biovariabilities, and these characteristics would lead to the mobility of CKD-related inorganic compounds through a competitive sorption or ion exchange. And we also made a class analysis of Spearman correlation between intensity of common molecules and factors. And we get 5 clusters. The cluster 3 have highest the correlations, followed by cluster 1, cluster 2, and cluster 4 and 5. And for cluster 3 and 1, this higher AS value and less AL value. So those values show close relationship with the CKD endemic. So this result further shows that CKD groundwater quality may be associated with DOM with more aromatic structure and less aliphatic structure in groundwater. And for season variation, and we use the unique molecules in wet season and dry season, and we get the HUSK, HUSHO, and HUSLO, these 2 index. And we can find that in the wet season, groundwater have lower ratio of oxygen to carbon, less Husserl, and more Husserl, which indicate that in from wet season to dry season, the Husserl was transferred from Husserl by means of oxidative degradation. And during this degradation, and we can know that DOC decrease, but fluoride and silicate increase. This is consistent with that DOM, the degradation induced the release of silica and fluoride in groundwater. And we also carry out some studies on fluoride removal by biochar in the laboratory. We used rice straw biochar and pre-treated those biochar by sodium hydroxide, and we also pre-treat the biochar by iron and aluminum solutions. And we get the maximum fluoride absorption is around 7 milligrams per gram. And the fluoride may absorb on biochar through heterogeneous molecular layers. And the coexisting anions affect the fluoride removal, which shows that the phosphate have highest competitive absorption, followed by bicarbonate, chloride, and sulfate. And we also may get some studies on the mineral phase change and the functional group changed during the absorption, and found that the ion exchange may be one of the important mechanism of fluoride absorption. So finally, I give a research perspective. Because of the endemic, and we cannot go to a Sri Lanka field site, but we get much assistance from Sri Lanka partners. They collect samples, water samples, and ship the samples to China. And they also make borehole in the field site to get the representative sediment, aqueous sediment, aquifer soils, and ship them to China. But unfortunately, although we have collected some bacterial samples from groundwater, but we cannot get those samples because of the customer regulation. So that is the conclusion I do not want to repeat, but we still have some, I think if we have more data, like environmental, geochemical factors, or like hydrodynamic conditions, land use, and utilization of pesticide, and we can maybe we can get a more better understanding of the CKDU factors and their relationship with the endemics. And also we need to know the key uptake pathway of CKDU risk factors, and we also need to remove the silica and dissolve organic matter from the related sample water to decrease the CKDU prevalence. So finally, this is our publications. Those publications was by Chinese side and Sri Lanka side. Finally, I want to thank my students and the collaborators, and also funding agencies. So thank you.
Thank you very much, Professor Guo, for your story from the Chinese team. And next, let's welcome the next speaker from Sri Lanka side about the topic of assessment of aquifer quality in relation with CKGU in dry zone of Sri Lanka. So shall we invite, let me see, Professor Hana, please, could you please start your presentation?
Okay, thank you. And can you hear me? I hope that you can.
Yes,
you all can hear
hear
me.
you.
Yeah. Okay. Just I wish to start my presentation with this statement. Hippocrates, who lived in the 5th century BC and is considered as the father of modern medicine, said, if you want to learn about the health of a population, look at the air they breathe, the water they drink, and the place where they live. This is the basis for our collaborative research work. Good morning, all Sri Lankan participants, and good afternoon, my Chinese colleagues and participants. Thank you, NSF, for allowing us to share our research highlights in this forum. And I believe that this is a very important event in the collaborative research between NSF and the NSFC. Yeah, I am very happy to see Professor Celian, my collaborator, as well as Professor Wei in the audience in the Chinese side. Actually, our collaborative study, we investigated the hydrogeochemistry of the Yan-Noya River Basin, which is considered as a CKDU hotspot, and also consisting of cold spots. Therefore, we thought that this basin is an ideal laboratory to investigate hydrogeochemical contribution to the onset of CKDU, one of the widely discussed research title in the last 10-20 years in Sri Lanka. Now, our joint research team in China, led by Professor Celian Lee, and I myself lead the project in Sri Lanka, and Dr. Nadisha Koralagedara and Professor Sunita Gunatilaka joined with me for the project. And we had one research student, Miss Charita Udeshani. Now she's in China at the moment. And Dr. Chamendra Vitana worked as a research scientist for a few months in the project period. And I think Chinese team will be introduced by the Chinese collaborators when they are presenting. Okay. Before moving into the project description, I used to explain why hydrogeochemistry is important in the Sri Lankan context. Sri Lanka is also characterized by uneven distribution of rainfall as well as the water resources. In part of Sri Lanka, we have plenty of water, and the rest is actually characterized with very low rainfall and also strong dry seasons. Therefore, the rock weathering is extensive in this region, as well as we can observe intensive leaching of some elements during the rainy season, as therefore it affects on the quality of groundwater. The groundwater in dry zone area is usually having remarkably high total dissolved solid values, and most importantly, majority of the population depend on groundwater as their primary source of drinking water. As you see here, mostly use protected dug wells as see here. I think most of our Chinese colleagues have seen this, and some of the people using deep wells which drilled into fractures in the metamorphic rocks. Now, therefore, the groundwater or hydrogeochemistry is interacting with the health issues of people. We can see dental fluorosis, skeletal fluorosis in this region because of the high fluoride, as explained by our previous speakers. And coming back to CKDU, I think you have seen this map previously. We have different type of nephropathies throughout the world with unknown etiology. And in Sri Lanka, we have this CKDU, and we are investigating this CKDU for last 20-25 years. But although in different countries, we observed the unknown etiology with CKDU or kidney disease with unknown etiology, they share very similar characteristics, particularly histopathological characteristics. Mostly these diseases are tubulointerstitial that could occur due to certain nephrotoxic agent or agents. That's why investigating drinking water in affected regions are important. Now, in Sri Lanka, CKDU is restricted to certain patches of the dry zone. And also we can observe some clustering in this region, although the CKDU is clustered in certain areas, but even within these clusters, we can observe certain patches. That means we call hot spot and cold spot. Now, as explained in the last presentation, there are plenty of suggestions for the reason for CKDU, but recent studies illuminated some of the early suggested factors such as high arsenic, high cadmium level in drinking water. Coming back into the main point of our problem, our research objective was developing conceptual approach and investigate integrative experimental tool to monitor and understand the transformation process of groundwater at the surface water, groundwater system, and the environmental geochemistry using isotopes. Basically, we considered the isotope is one of the very important tools to investigate groundwater, surface water interaction, as well as determining the impact, the groundwater, how the groundwater chemistry is changed once it is recharged into the aquifers. Now we selected Yarnoi because it has dry. It's completely a dry zone river basin, completely drains or flows through the dry zone, as well as it is having CKDU hotspots as well as cold spot. And our specific objectives were actually assessment of groundwater and surface water quality of the Yarnoi basin using combined approach of hydrogeochemistry and water isotopes, then differentiating hydrogeochemical pattern in the Yarnoi basin based on the water quality and also with the aquifer geology, and then correlating disease pattern with the groundwater quality because it is having both cold spot and hot spot. And then investigating the fate transformation of contaminant, and then evaluation of source of geochemical parameters and the isotope composition in groundwater in this selected region. Now, the research involved or research work has been carried out in the Department of Geology, University of Peradeniya, as well as the Institute of Surface Earth System Science, the Tianjin University. We started the project in 2019 and completed in 2023, and nearly 4.5 million rupees were allocated for the project. And we, as I informed you earlier, one research student as well as one postdoctoral research scientist were involved. Our research scientist is still, research student is still reading for her PhD. Now she's in China working with the same project. And we'll come to that later. These are the sampling points where we have collected samples, particularly in the post-monsoon season in 2021. We collected 90 water samples, and then pre-monsoon season in 2022, we collected 72 water samples. In addition, we collected some water samples from the wet zone area for the comparison purpose, particularly from southwestern part where we have lateritic aquifers. Okay. These are some of the field photos where we have collected water samples in the Yarnoi basin. We investigated geochemical and isotope composition of water samples. Basically, pH and EC we measured in the portable kits. We collected major cations, major anions, and some of the important isotopes. That work has been carried out in Tianjin University with the help of our Chinese collaborators. I think first time we investigated in Sri Lanka the sulfur isotopes and nitrogen isotopes in groundwater, as well as we try to date the groundwater using carbon-14 techniques. These are the parameters what we have studied. I think our Chinese colleagues will explain more on that. Cation anion analysis as well as trace element analysis we carried out in Sri Lanka, and isotope analysis we sent samples to the Chinese laboratory. Coming back into the research and discussion section, as explained in early presentation, we couldn't observe much difference in groundwater chemistry between cold spot and hot spot, but there are certain differences. As previous speakers mentioned, silicate weathering is most dominant, and actually most of our findings are more comparable with the findings explained in the previous previous project. Certain cases we can observe reverse ion exchange between minerals and the water, and also direct ion exchange as revealed from inorganic chemical parameters. These results are already published. And then we calculated the water quality index, and over 50% of the water in the region, in both hotspot and cold spot, are poor or very poor quality. That is very important. Then we have to do further studies and compare with the CKDU prevalence and the water quality index relevant to that particular region. This is actually one is for the dry season and one is for the wet season. Then we investigated water isotopes, and I'm not going to discuss in this detail because now the results are still being analyzed by our research student who is in China. And our conclusion, basic main conclusions up to now is more than 50% of the sample in both CKDU, cold spot, as well as hot spot exceed the maximum permissible limit in particularly the total alkalinity, total hardness, magnesium, as well as discussed in many studies, the fluoride. If you can consider mean concentration of hydrogeochemical parameters, usually it is high in hotspot compared to cold spot. And rock-water interactions are the main governing factor of the groundwater chemistry in the region, because the groundwater is highly modified, although after infiltration. And then magnesium factor is dominated in the hardness. Mostly hardness is temporary hardness, but magnesium is dominating factor compared to calcium 2+. The water quality index is actually affected by the fluoride concentration. Most of the early studies, they haven't considered fluoride as an important factor, but in Sri Lankan context, when we are calculating, if we are calculating water quality index, fluoride is one of the important parameter to be considered. And as well as we have observed certain good quality wells in the region, and that is important actually because most of the wells are bad, but still we can observe certain good quality wells within the region that is actually good for providing quality water, or can be used for public water supply schemes. Now, we haven't achieved almost all the objectives what we have planned because of certain difficulties what we faced during the project, but still data is being analyzing, and some samples are still to be analyzed in China. Due to COVID pandemic, actually planned collaborative work were hampered already. The Chinese team as well as Sri Lankan teams couldn't visit. Chinese team couldn't visit the field sites, as well as we were planned to visit isotope analytical laboratory, but it was planned in April 2020, but it was cancelled due to travel restriction. Particularly, we had a very good collaboration with the Chinese part, particularly for isotope analysis, and we are planning to send some more samples to Chinese lab pretty soon for interlaboratory comparison of trace elements. 2 research papers has been already published with the Chinese collaborators, and our research student is now in China carrying out remaining analytical work and completing research papers and also completing her PhD thesis. The research output is we couldn't find out very high amount of trace element in drinking water, something like arsenic or cadmium, lead, those parameter, fluoride, and water hardness, probably a possible risk factors of CKDU in trizone, and particularly the magnesium factor. And also groundwater is highly heterogeneous with respect to fluoride. We can observe high fluoride wells are located very close to low fluoride wells. that has to be investigated further. What is behind that, particularly the geological reasons. Shallow groundwater is highly modified compared to deep groundwater, particularly during the wet season or rainy season. And also the study, we measured stable isotopes of, that is nitrogen and oxygen isotope of nitrate, as well as sulfur and oxygen isotopes in sulfate. And probably we can identify sources of nitrogen and nitrate and sulfate in groundwater in the dry zone of Sri Lanka with these results. Now, I recommend to investigate all CKDU regions with respect to fluoride hardness, as well as compare with non-endemic region. We have to ensure, as mentioned in the early study, we have to ensure safe drinking water supply. That would be a positive intervention for mitigating the disease. Now we have encountered the good quality wells within the study area that could use as a public water supply, or even for purification for public water supply. Project was actually carried out with many difficulties, with financial and instrumental problem because of the problems with COVID that appeared in last 2-3 years. Sampling events were interrupted many times because of the closure. We have published 2 papers already, and a few more publications are on preparation, and we presented in two abstracts. And that is our study, and our Chinese collaborators will provide more information what they have done in Chinese side. Thank you very much for your attention, and thank you for NSF for providing this opportunity.
Yeah, no problem. Thank you very much, Professor Hanna, and I'm very impressed not only about your recommendation in practical level, but also for your other your suggestion and about the results and the output and the impact level, as well as your mentioned difficulties in terms of the financial and the instrumental level, and also with the pandemic influence. But in spite of all the difficulties, I think the achievement is very fruitful, and I'm very impressed about that. And next, I will invite the Chinese partner, Professor Li Liang. And Professor Li, please, could you please try to control your presentation in 10 minutes, please? Professor Li, please.
Thank you. Good morning, distinguished guests and distinguished professors. I'm Li from the Tianjin University. Just now, the Professor Chang just talking about our whole projects. So I will show this step-by-step background and objectives, measure result, and some impact, and possible build plan. In this room, everyone knows the recent numbers of CKDU patients in the north central province of Sri Lanka, especially in the rural dry zone. So we also know these people, they are young male farmers. So we also know they generally use the groundwater for drinking or cooking. So it's very necessary to research or study the groundwater qualities. So our research objectives in this study, firstly, is to clarify the water quality characteristics in the type of CKDU hotspots in the north central Sri Lanka. Professor Chandler just talked about the most part of that. The second is to understand the spatial pattern and what's like a reaction mechanism of drinking water quality in the CKDU areas. The third objective is to assess the coupling mechanism of regional water quality, environment quality especially, and the hydrological, biogeochemical process, especially impacted by the climate and some geology of land use process. This study area, the Yang Oyang River, the fifth largest river in the Sri Lanka. The Sri Lanka case also allow this. The land use there is natural forest and grassland. Some party field. The rainfall ranges from 1,200 to the 1,700, mostly contributed by the second into monsoon. The sixth water generally for the irrigation. We have carried out the 3 sampling campaigns. Of course, due to the COVID-19, the Sri Lanka colleagues carried out this samplings campaigns. At the 2021 dry season, in the cold sports, 25 groundwater samples were collected. In the 2022, the wet season, 90 water samples were collected, including the 84 groundwater samples. And the 2022 dry season, the 72 water samples were collected, including the 66 groundwater samples. This sample sites is such as surface water and the groundwater, mostly are groundwater and some through. We are analysis cation analysis the water chemistry such as nitrate, fluoride, sulfate, chloride, bicarbonate, sodium, potassium, calcium, magnesium, and we analysis isotopes in the changing university. The water isotopes, nitrate isotopes, including delta 15 nitrogen, delta 18 oxygen, sulfate isotopes, delta 13 for sulfate, and delta 18 oxygen isotopes, delta 13 carbon over DSA, and delta 14 carbon over DSA. Of course, today, because of time limitation, I just talking about the water isotopes and the nitrate isotopes and delta 13 carbon isotopes. We analysis trace metals, but today, because of time limitation, we didn't show that. For the groundwater chemical components, Professor Chandra just showed that the majority of groundwater samples belonged to the calcium, magnesium, bicarbonate type. Means this water generally impacted by the weather of carbonate and some silicon with mineral in this area. We analysis water isotopes. We could find the correlationship between the delta 18 oxygen over water and the delta D over water. In the wet season, we could find the surface water and groundwater exchange very fast. Means in this area the high precipitation. So the low observed significant variation between the high and cold spots. Because the water may just exchange very quickly. But in the dry season, we can do some difference between the surface water and the groundwater. The surface water generally enriches the heavy isotopes. So means evaporation shifts the isotopes of water. For the carbon biogeochemistry, we could this in wet season and this dry season. We could find that in the wet season, generally the soil CO2 contribute more carbon to the groundwater because DSA generally enriches the negative isotopes, the light isotopes. But we could find this color, this surface water, generally decussion occur. Decussion will shift the isotopes related to the DSA enrich the heavy isotopes. Because the decussion and some algal bloom or the atmospheric equilibration, the biological process will enrich the carbon isotopes in the surface stream. The slightly low delta 13 carbon values in the wet season means this water generally impacted by the carbon later weather driven by the soil CO2. And in this area, we find the carbon turnover rate is very quickly. because organic matter can be degraded very quickly, and organic carbon can transfer to inorganic carbon more faster. Of course, the soil respiration should be the major contributor to the DSA over groundwater, because in this groundwater, the delta ceiling carbon over DSA generally the values range from the -20 to the -10. This nitrogen biochemistry we also learn from this two figures is this is the wet season, this is in the dry season. The manual shows highly impacted, especially in the dry season. But in wet season, we could find the fertilizer more contributed for the groundwater. And in the wet season, we could find the bigger storm and the bigger rainfall will contribute some nitrogen to the groundwater. And we could find the positive relationship between the delta 50 nitrogen and the delta 80 oxygen over nitrogen. Means the denitrification should occur, especially in the wet season. Based on data, we make an assessment of the water quality in this catchment. Of course, Professor Chandra just talked about that. In the cold spots, about 50–80% of water samples were in the excellent and good categories. And in the hot spots, only 51% of were within the safe limits. We have collected data from Kawakami, and this data about including the 1,304 water samples and data. We make the land use and geological map and analysis temperature and precipitation in whole the regional scale. I think this is the first time to analysis whole this many data in the regional scale in the map. This is the land use and this is geological. And this elevation and precipitation temperature and the district mostly affected by the CKTU. Or you could find the different parameters, especially the water temperature data in the different zone. This nitrate, the first figure, and this is fluoride, the hardness, this fluoride, and this fluoride, the max value, and this arsenic, and this CD, and iron, Mn, and copper, and Cr, and Pb, and alumina. In this figure, we could find the hardness and the fluoride also show high concentration in the dry zone, and 90.9% of samples had a concentration higher than that is the WHO guideline over 1.5 milligram per liter. The max arsenic concentrations over samples in the 4 districts were higher than the WHO guidelines and the Sri Lanka standard values, especially in the coast zone for arsenic. But other heavy metals generally is that high, so it's good news. For a whole groundwater assessment based on the nitrate and the hardness and the fluid, we could find the positive relationship between the nitrate concentration and the water hardness. And with the chloride, this figure, and the arsenic concentration had a positive relationship with unconsolidated sediments, implying the important effects of land use and the geology on the groundwater geochemistry. So the hardness and fluoride and arsenic concentration because were positive correlated with precipitation and the negative correlated with air temperature, means a very clear difference in the groundwater quality impacted by the climate. So it's interesting. So we got some that conclusion So the first, the Professor Chandra just talked about that, and we also allow the surface water and groundwater exchange very quickly. So in the monsoon seasons, the pollutant will transport very quickly and will deteriorate the groundwater quality. And the petrochemical process now the proof shows that in fast in the study area, especially in the organic matter transport inorganic carbon and nitrogen denitrification. Meanwhile, the nitrogen isotopic signature showed that the manual and fertilizer contributed more during both two seasons. But in the wet season, the fertilizer is a major contribution. Beauty. We also now need the analysis of multi-factors, including the land use and some geology, some temperature and precipitation. Of course, we think this project improves the research on the stable isotopic chemistry over groundwater in Sri Lanka. Of course, because we carry out this project, so other people invited I to give the invited talk about the Sri Lanka water and the friendship between China and Sri Lanka. At the same time, we cultivated the young students from Sri Lanka. Now she's here, and until 2019. I invited the visiting student in China to some experience such as isotopic analysis. Now she's go to Germany for her PhD career. In my group, some co-PhDs, young scientists promoted to professor or associate professors. And in Chinese side, we published six essay papers. Of course, there is a limited paper about the Sri Lanka groundwater, some paper about the method. That's it. In future, we think we should think more and do some more analysis, such as detailed information over in a smaller catchment and a small village. We should do some analysis. In future, if possible, if more funding, we think about a high frequency center or something. Maybe we can give more information or better understand to the water quality dynamics in this area. We think we should assess the water resilience time and the element turnover time. Use this to assess the water quality. Of course, we need the factors analysis or big data analysis to assess the water quality and give some certain sustainable management suggestions. Thank you very much.
Thank you very much. Let me add, from the point of view of the Science Foundation, we especially impressed by your last 3 and 4 slides. It's not only from the point of view of the matrix of the science talent and the networking, but also you can have the plan and to have from the top down point of view, and we're very impressed about that. And next presentation, we will welcome the Sri Lanka PI with the topic of the membrane folding mechanism and control high pressure membrane in the CKTU effect area of Sri Lanka. And we have the Sri Lanka PI here in the main conference room, and let's welcome Professor Shaman to give the presentation. Thank you very much.
Thank you. Hope the Sri Lankan participants can see and hear me. So I would like to start the presentation. The collaborative project topic was membrane fouling mechanism and control high pressure membrane processes in NFRO systems and electrodialysis, purifying groundwater with dissolved organic matter and high hardness in CQD affected areas of Sri Lanka. So my project from Sri Lanka side, I'm the principal investigator, and the Chinese Academy of Sciences, the Professor Yang Song Wei is the PI from the China side. Okay, and this is mostly the related or the focused on the treatment aspects of the CKD, I mean water in the CKD affected areas. So how we line up our project, what are the steps that we study, sequences that we followed in this project. So we did some characterization and spatial temporal distribution, especially the dissolved organic matter in groundwater of CKD affected areas to understand how the variations, and then the evaluation of performance of membrane fouling of reverse osmosis systems and nanofiltration systems in drinking water stations in CKD affected areas. So we did a study looking at what is the status of current systems of the RO and NF systems. Then with that background, we come up with the provide effective and stable control technology for purifying groundwater with dissolved organic matter and high hardness on this area. In the same time, other technology we were looking at was the electrodialysis, the membrane fouling mechanism to control the system with the dissolved organic matter and high hardness, and also the membrane fouling mechanism and control the NF purifying groundwater with DOM and high hardness. Basically, we were looking at how these systems or the membranes fouling mechanisms due to dissolved organic matter and high hardness and the control mechanisms, and also the long-term stable operation for nanofiltration and ED systems for the CKDU grounded effect, I mean CKDU affected areas. So looking at the community level applications with the support of national water organizations in Sri Lanka. I would like to highlight actually the most important part of our research is this collaborative approach, where actually with the initiation that we brought the EDR plants from China to our laboratory, the two treatment plants or the laboratory scale models, and also the membranes we brought up from the help of Chinese RCs. And this is visits by the collaborators physically and online, and the contributions at conferences by the Prof. Wei and our main PI and also other teams in this journey. And the sample analysis, that is another special aspect that we jointly do. So, and research meetings were conducted every once in 2 weeks. Most of the time, even we passed the due to the COVID period. And so we had a I just want to highlight especially this collaborative effort on this research. It's not the individual research that we carried out. This is the special, the project that we carried out, and we succeed with the joint publications, joint collaborations, and the capacity development from the both sides. So as I mentioned, we use the technology with the nanofiltration and the EDR for the laboratory scale. We developed the laboratory models, and we studied the in presence of dissolved organic matter, and also we studied what are the mechanisms that this membrane fouling can happen under the presence of the metals, so that the potential of DOC metal complexes in this area groundwater and how it contributes to the membrane fouling. And in addition, that identify the fouling mechanisms of humic acid, fulvic acid with EDR membranes in addition to that, and NF membranes during the purification of NCP groundwater. In addition, the cleaning procedure of these membranes. Furthermore, with this study, we identify the proper pre-treatment techniques when you run with the DOC and hardness for the membrane systems, and identifying the major drawbacks associated with the sustainable operation of village-based these groundwater purification systems. So this during the study, we carried out this parallelly how the sustainability of the NF and RO, nanofiltration and RO systems implemented in the CKD affected areas, there are what are the factors that affecting their performance and importance of operation and maintenance, to identify what type of technology or what is the best we call appropriate technology or customized technology that we need to treat this groundwater depending on after looking at the groundwater. So what we were looking at, we are coming up with this study. And also the importance of SLS standard for the DOC content in drinking water. That one also recommended by us to the National Water Supply Drainage Board and the Community Water Department, and to the further to see how we can take up for the next level for the implementation. So major findings, there were, more than that, but I was trying to bring few of that. Because of this, the dissolved organic carbon and the hardness, when you run with our membranes, it's easily get the fouling, and the dissolved organic carbon complex like calcium, magnesium, aluminum, and most the probable complexes that form in the groundwater, and this contribute to the membrane fouling. And also we try to identify the ratio of these fractions, and how these chemical composition and chemical interactions and kinetics could affect this membrane fouling. So this is kind of theoretically we identified. So this will helpful to see the control mechanisms, as well as the develop some kind of method to control membrane fouling, and in addition to sustainable operation of these systems in these areas where we have adapted the RO and NF systems. So it's basically that maybe this is, someone can say, obvious thing, that groundwater may be not suitable for the drinking, direct consumption without treatment, but whether people aware on this. So we have to revisit these sites, or revisit our consistency whether people are aware on this, and proper cost comparison, and considering the operation and maintenance we have to do, because we are mostly implemented on the reverse osmosis systems in Sri Lanka, whether it's the most suitable. So we came up some light of the nanofiltration systems that may be more appropriate for certain groundwater quality or some of the areas. So we need further studies on this, and especially also pre-treatment methods for integrating RO and nanofiltration systems. So this is another outcome of our study we would like to share with you, and also we have taken up with the National Community Water Department the concept of the sustainable operation of this nanofiltration, but this can be applicable for any other type of community base. So kind of guidelines for the establishment or the installation of the plants, whether what is the criteria for that one, and the community engagement, because throughout the period, to what extent we are discussing with the community to identify their needs, and have the dialogue with all the communities, the technical support throughout the period, awareness on the water quality on the community, and also the regular operation and maintenance. So this is the key factor that we noted on the implementation of these units I mean, of course, we carried out the research at, very successful manner, but same time we were looking at how this is going to implement and what are the drawbacks on the other side for the next level it's implementing. This is another dimension of the very nice dimension that our students who studied with us. Some of them actually now joined the university as senior lecturers. Mr. Suresh is there. I think he is doing the PhD with the Chinese Academy of Sciences, and one student she is doing the PhD in USA. So this is the one other, and all our publications were collaborative publications, the top level publications. We had conference proceedings and some of the workshops, awareness programs. With the great support of the Chinese collaborator, other co-PI, President Songwei, and we had a team working together for this, the National Water Supply and Drainage Board, Dr. Veeraguda was with us, and the National Institute of Fundamental Studies, Professor Rohan Veerasuriya, and so we were together in this project with the Professor Nanishani and Professor Atulan, from the University of Peradeniya, University of Rajarata, and it was a nice journey that we came out with not only with the academic, not only with the community engagement, but also with the supporting young scientists and building up with the working with the at the international the successful collaboration. And I'm very much thankful to National Science Foundation and NSFC China for supporting this project, and we had a very kind of difficult period during last few years, so it was a great strength for us for this kind of project, like to support the research or to carry out the research during this difficult period. So thank you.
Thank you very much, Professor Sherman. We especially appreciate your point of view, not only from the talent cultivation of the environmental engineering level, but also from your angle for to consider all your project and also the problem from the sustainable development view, and it's a very universal concept and language. And from Professor Sherman's presentation, mentioned the Professor Wei Yuansong working as the resource person and the key contact person for their corporation, and not only for their corporation, I think also for this cluster program actually. And next, let's welcome Professor Wei Yuansong to give the presentation from his point of view. Professor Wei, please. 10 minutes.
Yeah. Many thanks, Mr. Long Yan, for introduction. So it's a pleasure. Okay. Yeah. So, ladies and gentlemen, good afternoon. So many thanks for your attention. So many thanks for the Mr. Long's introduction. I will follow in the Professor Xiamin's our presentation. So I will seek the burning issue. So this project focus on this one, tackling the CDU and providing the safe drinking water. So for our this is the research, the purpose is very clear, and this is our technical roadmap. So this diagnosis to understand the water quality and water supply in the CDU affected area, and then we need to develop cost-effective, custom-tailored technology like the EDI and nanofiltration. Then this is the EDI technology and the nanofiltration for the drinking water supply. One is EDI for the centralized water supply, and nanofiltration for decentralized drinking water supply. So all of this make the demonstration, then we'll provide the solution for Sri Lanka safe drinking water supply and water for all. This is for the master plan. That is our purpose. So, and there are the 4 research countries. Okay. So, and in the past, so with our cooperation, so we do lots of things like the sampling in focusing on the North Central province, and we collect more than 500 the samples. But this one is very integrated. So I will do that. There is more than 300 samples, shallow well and the tube well, and also springs. So this is the dark well, this is the tube well. So you can see this one. So because this is common used in Sri Lanka rural area. So we also make investigation. Our drinking water stations in the NCP, there are more than 100 drinking stations for investigate. So this is our students do this investigation, and this is drinking station. So the first, I think, for the major findings, so that is we are very happy to build a groundwater quality atlas in the NCP, because in Sri Lanka the water quality data is shortage, is like, so this is not the, this is the base. So if with this one, then we can for the drinking water supply, for the security tackling, and also for something like that. So this is very important for us. For example, based on our research, so there is the groundwater type is calcium hydroxide type. This one. So this is similar to all of you, and also there's a higher EC in the center, but the higher EC found in the Annapurna, it means the water quality in the Annapurna was worse than the Ponnan. That is, and this is because that two multi-parameter just shows this one, and also this is the ions in the water system, and also we make the water quality assessment. So based on the water quality assessment, including TOC, because the TOC in the past was not measured by the Sri Lanka. So we use this one, including the TOC. The water quality in this area are not so good. So you can see most of this should be treated. So that is very clear. That is very useful for the decision makers. Okay. Okay. So we also make the impact the annular patching influence on water quality. So in groundwater, shallow water. So that is very clear. The municipal sewage wastewater. So you can see the animal agriculture and the landfill, and also some of the nitrate from the inorganic fertilizers and the urban landfill and municipal sewage wastewater. So from this, so we can very clear to understand the contamination in the groundwater. So that is also for us to select suitable technology. It's very useful. And this is for the water quality investigation. We include the inorganic ions, organic, and also microbiome. This is for the organic. This is for us. This is our first to make the DLM in the Sri Lanka side. So this is we also compare the dark well and the tube well. So that is very interesting. So generally the DOC is higher than 5 milligrams per liter. Is higher than the drinking water standards of China, but in Sri Lanka drinking water standards no. So there's the DLM should be pay more attention in the future. And also we also make the microbiome community investigation. So there in the CKD prevalence can significantly affect antibiotic resistance, and the microbiome community is very new. And so that is foundation. So it's also very helpful for us to understand there is a microbiome community antibiotics resistance in the groundwater. So and also we want, because the DLM maybe also play a very important role for the membrane folio. So we want to know what is the DLM, the characteristics and the interaction with other chemicals. Like so we do something to this. So the calcium and the magnesium in the this is the high rate, the CKD patients, they will act with these function groups. Maybe they will cause membrane falling, So this will also maybe cause some CKDU, but we are still do some research. And then based on this water quality atlas and water quality assessment, so we can know to recommend the suitable technology for local government. So you can select based on this water quality, you can select a suitable water treatment technology for the local people. And so this is for the basic work. And also we make the field investigation. We assessment performance our drinking water station in the NCP. We found all of them, the treated water can meet the drinking water standard, but the best one for the salt rejection is the two-stage business tree arrangement like this one. So others, our drinking water station is not so good. So because for the compare the cost, so that is good for local people to select this suitable the RO drinking water stations. And also this is for the but we need to develop the customer cost effective technology for Sri Lanka. This is for the concentrated water supply. We develop the EDR technology because we know in the CKD area the hardness and fluoride there. So how to separate? So we use this technology EDR. So you can select separate fluoride, and for this, then this will be achieve very high remove for this is fluoride. So based on this, we also do the membrane falling and scaling. So we found that in the scaling, like this is the chemicals and how to control this scaling. We developed this technology, passing adding acid in electrode chamber, so we can control. So this is the scaling and maintain this long-term stable operation. And also in the past several years, this is the long-term operation, so we can maintain the high water production, water recovery, and easy the water quality. All of this is very stable, so it can meet the Sri Lanka drinking water standards. And also this is for the centralized water supply. For the decentralized water supply, we select the suitable nanofiltration membrane. Based on this process, we select, compare lots of more than 10 types of nanofiltration membranes. Then we can develop this technology and make a custom tailored nanofiltration. This is my PhD students. And then based on this, so we want to know what is the problem membrane falling mechanism for the nanofiltration. We also there from the inlet, mid, and outlet, the different stage. So including the inorganic, the salt, this different salt, and the organic position and the microbial community. So all of this we make investigation. Then we propose the membrane falling formation process in the on the nanofiltration membranes. So this is for the membrane falling mechanism nanofiltration. Based on this, so we can want to know how to control, how to do that. We use the clean strategy, use different the acid and alkaline. So we find the combination is much better. Combination is much better. But which one? So acid is first acid, then alkaline, because the scaling plays a more important role for the membrane falling of nanofiltration. And this also for the long-term stable operation since 2018 till now. The produced water quality is very excellent and stable, and also can meet the Sri Lanka drinking water standards. So that is our demonstration there. So it can provide the over 5,000 villages, including 1,300 primary school students. This is for the EDR, this is for the nanofiltration. And also, and as mentioned, Professor Shannon, so we in the past from our side, there are 14 tables, including the pen. share papers for the presentation over 10. And but for the parent cultivation, there are 6 students, 2 Sri Lanka students finished, and Paris and Matu, and 1 Sri Lanka master, but Indica still continue his PhD study, and my Chinese student also continue his PhD study. So that's all. Thanks. Thank you. Thank you all. Yeah.
Thank you very much, Professor Wei. We're very impressed about your atlas-based water quality analysis, which is science level, but also the water treatment atlas, and which is the engineering level, and all of that have a lot to do with all your great field investigation with your Sri Lanka partner, Professor Sharma. Thank you very much, Professor Wei. And next, let's welcome our last presentation, first from the Sri Lanka PI, and with the title Novel Urinary Biomarkers for Early Detection of CKDU. And the last one actually is from the clinical point of view, and we are very looking forward to that. Let's welcome. Let me see. Yes. Professor.
Okay.
Yes, please.
Yeah, thank you very much. Let me thank the National Science Foundation of China and the National Science Foundation of Sri Lanka for organizing this research program. I know that it is one of the most looked after things in the program, but we'll go and see. But we had certain issues coming up regarding the study on novel urinary biomarkers for early detection of chronic kidney disease of unknown etiology in Sri Lanka. So the team was initially, the PI was Professor Kamini Vanigusurya, but on her retirement from the faculty, I took over in end of last year. And this is our research team from Sri Lanka and from the Chinese side. So the objectives of the project were to evaluate, as the title mentioned, kidney injury biomarkers among individuals living in CKDU endemic areas and non-endemic areas to identify effective biomarkers with the idea of detecting CKDU early. And as most of you must be familiar, the main issue that we have is that the detection is late, and by that time, their survivability is compromised. And so if we can detect the disease early, chance of survival hopefully will be better. So the specific objectives with that general objective in mind was to identify sensitive and effective urinary biomarkers for the early detection of individuals with CKDU. And going on from that, to determine the cutoff values of the urinary biomarkers in comparison to normal individuals, which we were planning to take from non-endemic areas. And then this is the main part from the Chinese collaborators, study of urine proteomics by mass spectrometry in all subjects with a way to identify the pattern of proteomics in the early stages of CKDU. So our study design was a cross-sectional study with longitudinal follow-up. So we had 2 areas, this endemic regions, Madhavachi and Padavi in North Central Province, the initially selected areas. And then the non-endemic region, Vurlesguma in the Western Province, where we were recruiting healthy adults. So the number that we were, study population was adults aged 30 to 75 years living in CKDU endemic and non-endemic areas. We're not going to go through the inclusion-exclusion criteria here. And the sample size was 225 each from both the endemic and non-endemic regions. So going into the study variables, we were collecting the demographic data, the anthropometric measurements, blood pressure, random blood sugar, hemoglobin A1C, serum creatinine and estimation of the GFR. Serum cystatin, we ran into issue because the test was discontinued in Sri Lanka and none was available through the companies that supplied us these. Then looking at the urinary albumin to creatinine ratio, and most importantly, the kidney injury biomarkers in urine as listed here. So sample collection and analysis, initial sample collection in the CKDU non-endemic area has been completed. And all the samples at the moment have been analyzed, both biochemical testing and the ELISA for the kidney-specific biomarkers. The sample collection in the CKDU endemic area has been completed with the support of the Renal Disease Prevention and Research Unit of the Ministry of Health in Sri Lanka. But we ran into issues because of the difficulties in purchasing reagents at the high cost of analysis, going with the allocated funds for this, and also the released fund from the National Science Foundation. So that is what we are highlighting here. Available funds are not sufficient to purchase ELISA kits to analyze samples collected from CKDU endemic area. I'll come to the details in the later stages. And then the next one is the follow-up study, which was one of the most important ones that we were planning on. The initial plan was to do a 6-month follow-up in the CKDU endemic areas, which was due in June 2023. And again, we were not able to do that due to lack of funds, in the sense that us not being able to get the funds to start the project, second part of the project. So urine samples of 10 ml from 100 CKDU endemic and non-endemic partners are stored at -8 for proteomic studies in China. And we were able to only send about 26 pairs sent so far. So this is where our researchers have gone, especially our postgraduate student, Ms. Kalani, and she has been able to get, with the help of the people whom you see here, especially from the Ministry of Health, the volunteers' faces have been blacked out, but the others have been kept as it is. So we have been able to collect almost all the samples, but we have run into issues with analysis. So coming into the results as such, data collected from the non-endemic control group is being analyzed, both biochemical and ELISA, as I mentioned. And we are planning to complete the investigations of endemic samples within this month. But again, we have an issue with that, as I mentioned previously. The ELISA test for 5 urinary biomarkers cannot be analyzed because of lack of funds as of now. Since samples collected from endemic areas are still not analyzed, the impact or the effect cannot be determined as yet, and the comparative analysis has to be performed. And we are hoping that we will be getting the next set of funds to continue with the study. But obviously, the 6 months duration is over, but we can still go on, because we can sort of change and get the ethics approval and go even for about 9 months later. Still, it will be worth doing that part of the study if we can get the fund. So as I mentioned, without analyzing the endemic samples, we cannot do the comparison, and we are stuck at that level at the moment. So this is what we are planning at the moment. Data analysis is going on. Follow-up of positive cases. Hopefully we can do in October if we get the funds. Again, the same for the ELISA. Finalizing the study, if we do not get the funds, we'll have to do by at least November due to the deadline given, based on what we have done already only. But we are hopeful that if we can get the necessary funds again, the release of the originally given funds, we will be able to finish the project and do the comparison within 8 to 12 months. So limitations, we ran into 2 major limitations, not just the lack of funds. This is the study that human contact was there. So the lockdowns due to the COVID pandemic went on for months, as everybody knows. And then it prevented from conducting field visits for sample collection. And even after the lockdown was over, there were certain restrictions and the reluctance on the part of some of the volunteers for us coming in and doing study, but they were very cooperative. Even with all these difficulties, we were able to collect the samples, but still it took us more than a year to complete from the date of sample collection. Then another issue is the major delays in shipments of audit equipment and consumables due to COVID-19 pandemic. And also because of that delay, we ran into another issue that faced the whole country, Sri Lanka, the financial and the fuel crisis. which again prevented us getting the samples collected on time. But still, with greatest difficulty, I have to really thank Ms. Kalani and the collaborators from the Ministry of Health. They were able to collect the samples, at least the initial samples. So insufficiency of funds received from available balance of funds is the major issue that we are having at the moment. So as you can see, from the pledged 21 million, we have got about 36.96% as of now, that is up to December, allocation for 2022. So at the moment, the balance is around 13 million Sri Lankan rupees. So if you are able to get that, even within the budget, I think still we can do that with the help of Professor Saxi and the collaborators in China doing the proteomics part without our student going to China. But if we are to send the student there, we may need a little bit more extra for this purpose. So although I know that all of you were looking forward to the outcomes, at the moment, we are not in a position to come up with the outcomes from the Sri Lankan side because of this. And we hope that we will still be able to continue, because I think, as all of you would know, this is one major part that we have to do if we are to really sort of get help for these people who are living in these endemic areas. So thank you very much, and over to you.
Thank you very much, Professor Chengju. Thank you very much for your presentation, and especially your very straightforward explain and information about the difficulties and the obstacles you faced during the project. And we are very looking forward to the future plan for the project. And last but not least, let's welcome Professor Wang Fuxia, and he's from the Peking University Hospital, and we're very looking forward to Professor Wang's presentation. Let's welcome Professor Wang.
Thank you for introduction of Mr. Nian, Mr. Rong, and also I'm grateful for have this opportunity to present my research. And my topic is about the pathological study and the novel urinary biomarkers on CKDU of Sri Lanka. And the co-PI from the Sri Lanka is the Professor Chandu from the Department of Pathology of the Columbia University of Colombo. And also for the biomarker study is from cooperated with the Professor Kamani Wagsurya. And I'm sorry, now the current PI is Radhika Pereira, just give our report. And now, as you know, the CKDU is chronic kidney disease. It not attribute the traditional causes like hypertension, diabetes, and other etiology. So we do not know the etiology. So the previous study have given a lot of study to look for the possible factors. Now it is a very critical issue because the incidence of CKDU is as high as 30%, and also is the maybe the 7th or 8th leading causes in the Sri Lanka. now about the pathological finding of the kidney disease will give some important clues to point the etiology of the kidney disease. So by the renal biopsy, we can find the first report about the CKDU is about the feature is the tubular interstitial fibrosis with tubular atrophy. But this feature is the common finding of the 8-stage kidney disease. So is it really just a tubular interstitial disease? The followed report have given us some studies showed we also have found the global sclerosis, interstitial inflammation, and other vascular injury, just like the arterial helinosis, can be found in the biopsy of the CKDU. Also, there another report shows the toxic injury by the proximal tubular injury identified by the electron microscopy. In the summary, there is a systemic this systemic review by the professor from the University of Columbus has just summarized all the morphologic features published, and the major prominent lesions is the interstitial fibrosis, but it is the final stage, it's the chronic stage. We do not know the early lesions. So the other papers have showed maybe there are some glomerular disease leading to the glomerular sclerosis. And also maybe the ischemia-related renal injury, including the vascular arteriolar sclerosis, may contribute to this disease. In all, this systemic review gave us this conclusion. The characteristic pathology of CKDU has not been unanimously recognized. So the renal fibrosis only is the common final stage of the ESKD. Because the previous study have some limitations, there are some heterogeneity in the case selection, in the biopsy reporting. So formal description or systemic evaluation of the renal biopsy is essential to draw a conclusion. So for the final stage of this CKDU, we can see the renal fibrosis. And the renal fibrosis because the proliferation of myofibroblasts can produce the collagen and leading to the renal fibrosis. So for the to find the pathogenesis of the renal fibrosis, we should look for the origin of the myofibroblast. Here is some hypothesis. Is with the tubular injury, maybe it can the epithelial mesenchymal transition EMT occurred to evolve into the myofibroblast. Maybe there are the inflammatory cell infiltration can also produce the macrophage myofibroblast transition, and also maybe derived from the endothelial cells. And here is the hypothesis. So far, we hadn't found the key cells contribute to the myofibroblasts. And we do not know the pathogenesis of the renal fibrosis in this patient. And for the early diagnosis, just like the Professor Rasica reported, we try to find the early biomarkers to diagnose this patient. And so far, here is some urinary biomarkers we routinely used. And this part will be performed by my collaborator. And this part, the biomarkers to distinguish CKDU from CKD by mass spectrometry were performed in our laboratory. We can use the liquid chromatography and the mass spectrometry to screening the differential expressed protein and try to find the novel biomarkers in the CKDU patients. So the research project in my grant, I include the following. Part one, we try to assessment the pathological features, renal biopsy of the patient with CKDU. This is a retrospective study on the periphery section renal biopsy to evaluate the glomerular, tubular, interstitial, and vascular lesions based on light microscopy. Part two, we can try to identify the marker for the micro co-localization with the myofibroblast. So we use the marker, the fibroblast, FSP1 and alpha, smooth muscle actin, and also co-localize with the tubular epithelial, E category, and macrophage CD68, and endothelial CD31 by confocal immunofluorescence. And part three, we try to investigate the urinary biomarkers of CKDU by proteomics based on the mass spectrometry to find the differential expressed proteins between CKDU and the control. The result, part one, here I only get several patients of the CKDU. Here is the mainly morphology features. We can find indeed the tubular interstitial nephritis. You will see the interstitial inflammation and the tubular injury may be the major finding. And also along in the chronic stage, you will find the interstitial fibrosis. In addition, you cannot neglect the glomerular lesions. So you will see the quite a lot of glomerular sclerosis, also with the vascular lesion. So we try to find the etiology from the view of the morphology. So we compare the pathological features between the CKDU and the CKD with known etiology, such as the hypertension-related CKD and the acute tubular interstitial nephropathy-related CKD. This from our hospital as the control patient. So we compare the pathological features among these three groups. And we found the glomerular sclerosis and the IFTA, the interstitial fibrosis and tubular atrophy, and also the arterial sclerosis, the vascular lesions, were very similar between the hypertension-related CKD and the CKDU from Sri Lanka. So our study showed the CKDU possessed similar features of the CKD derived from the hypertension. Here is the renal biopsy finding from the hypertension-related CKD. Indeed, but we'll see there is ischemic global sclerosis and arterial sclerosis. So this morphology suggested that maybe there are similar features between the CKDU and the ischemia related in kidney injury. And also we have found the interstitial inflammatory cells, some are from the macrophage, so the CD68 positive. So part 2, we try to identify the origin of this myofibroblast. We perform the confocal immunofluorescence. So here is the alpha SMA, and here is the tubular marker, carry. Here the merge, you will find the colocalization of this marker. Also, we also found here is the SMA, and here it is CD68, the macrophage, partly colocalized. So this study showed some existence of the EMT, the epithelial cell transition to the myofibroblast and macrophage myoblast transition. Part 3, we investigate the urinary biomarker. So I really appreciated the collaboration from the Professor Rasica and his fellow Klani. They set the sample, collect the urinary sample. Here you by the LC-MS analysis, you will see the CKDU and the control have separated completely. Here shows the down-regulated protease. Here is the here is the down-regulated protease. Here is the up-regulated protease. Geo-enrichment analysis will show here is the up-regulated protease, and here is the down-regulated protease. And by KEGG pathway analysis, we also see the series, the activated pathway, including the complement coagulation, or even we detected the COVID-19 infection in this patient. This is the down-regulated protease in the urine. We summarize the differential regulated protease. We found the up-regulated pathways, including complement and coagulation cascade. And the infection, indeed, this patient in this pandemic time, so we also detected COVID-19. And also some protein processing in endoplasmic reticulum, protein digestion, absorption, and cholesterol metabolism. So this protease, the pathways show the up-regulated pathway, including immune response, and infection may be related to the COVID-19 infection. And also this shows the abnormal metabolism in the protein and the lipid. And the down-regulated pathways show the cell adhesion molecules and the focal adhesion and the extracellular matrix receptor interaction. This pointed to the EMT, the epithelial myofibroblast transition, and also suggested the renal fibrosis. And this the decreased pathways, including lysosome endocytosis, is point to the cellular degradation in this patient. Also fluid shear stress and atherosclerosis. This is related to the blood regulation, maybe related to the hypertension and atherosclerosis. This is the protein interaction PPI network according to the differential expressed protein. Here is the up regulation proteins. You will see the protein interaction. This shows the down-regulated proteins. So we analyzed this string PPI map. We found for the key upregulated proteins, maybe we found this lipoprotein A4, and this protein is related to the fatty acid metabolism, maybe related to atherosclerosis. And also these proteins showed with in some studies is related to the renal fibrosis. And AGT, agitation, is related to the blood regulation. So that suggests the hypertension. For the key down-regulated proteins, we also found the cell adhesion molecules, ICAM1 and CADM1 and PACAM1. This again suggested the EMT and further leading to the renal fibrosis. And although we have found the KTK-related proteins, this related the tubular injury, and also the thrombomodulin is related to coagulation. In final line, according to our study, we found the pathology of CKDU manifest not only the tubular interstitial nephropathy, but also showed the ischemic related injury, including ischemic glomerulosclerosis, arteriosclerosis. And the origin of the myofibroblast may derive from the EMT or MMIT. This result suggests the target therapy to the tubular injury and the inhibition of the macrophage. And for the final line, the urinary proteomics by MS suggested that their abnormal metabolism in fatty acid and also cholesterol and blood regulation and coagulation, as well as immune response and infection. And finally, this may be related to the COVID-19 infection, but this fatty acid metabolism and the blood regulation may more quality give our clue this patient may relate to the ischemia, to the atherosclerosis. So that's the finding our study. I really appreciate my collaborator from Sri Lanka, Professor Chandu, Professor Kamani Vanisuriya, and Professor Rasika, and also the Asanga Pubudu from the Ministry of Health. And our colleague from the Department of Nephrology, Professor Minghui Zhao, Professor Li Qiangmeng, and Professor Lu Xiazhang, and are really grateful for the NSFC support. Thank you.
Well, thank you very much, Professor Wang, for your fundamental and also the original work about the clinical work of CKDU, and from the actually from the previous 8 presentations from all the different 4 projects, you can see there's great potential for the integration and also the linkage of all the 4 projects, and we can maybe it's also serving as the basis for the future cooperation of NSFC and the NSF. And for the time issue, and we can have the brief Q&A and a discussion session. And the floor is not only open to all the PIs just give the presentation, but also for the audience and our colleagues from our two foundations. The floor is yours. Is there any questions? Yes, Professor Sherman, please.
Thank you. I think very interesting. The other projects also we learn a lot from the projects. I would like to suggest whether from these 4 projects, whether we can come up with some kind of we call perspective document that kind of concept note or kind of thing that outcome as a nice booklet, not a academic publication, but kind of as outcome be produced to the, I mean, which can be understood by any person and maybe the administrator or any level, how this contribute to the society and the decision makers. This can helpful our findings. This is just a suggestion.
Professor Shamin, very important suggestion. In fact, National Science Foundation is in the process of formulating policy briefs, not in the high technical level, but in layman language. Policy briefs are targeted knowledge mobilization, not just dissemination. The outcomes, findings, key recommendations from research to the decision-making level, to the relevant stakeholders mobilizing. So NSF already in the process of I think first camera ready version of previous research, one policy brief already about to out. We can, NSF can facilitate, initiate the second policy brief on overall this project. Both, I mean, not only for it, policy brief could be use of both side, addressing the both countries' relevance. It could be formulated, and we need, in that sense, we need support from all the core team, research team members to get the, I observe some continuation of data collection and analysis part yet to be done. So my humble request from all the principal investigators and co-investigators to cooperate closely and give your data and findings in a concise way, so that we could work together jointly with the NSFC and NSF, kind of a apex level kind of a document in a digested way to convey the key messages to the decision-making level, as well as same could be in a way used as a knowledge dissemination or awareness raising to the community level, maybe with modified form. So we, of course, NSF has format. We can share with the NSFC and all the research team members for the what we expect from the, I mean, in a way, in the content-wise in the policy brief. Yeah, a very, very good suggestion. I very much appreciate in the way of getting the message to the relevant stakeholders and decision-making level. We can support in facilitate that process.
Sometimes. So I have some suggestion, because we are for project do lots of field investigation about groundwater quality in Sri Lanka. So that in different, we are in the north central, maybe others in the different side. So it is impossible NSF organize do some special report for the water quality. It is just like a baseline for your country. So your country for the water for all. And so we can baseline to report your government means what supply and that is the outcome, outcome. So maybe it's also useful for future for NSF to get more support from your government. Yeah, that is this is the first because there's lots of data about the water quality in around Sri Lanka island country. That would be a good way.
Yeah. Professor Wei, thank you very much. You suggesting it sounds, apart from the overall key recommendations, you sound kind of a document the data based on groundwater and water quality and water down chemistry, everything to be as a compendium in a documented manner, which will be very useful in future. Of course, my head of research division here, I'm sure they will also work towards that direction, preparation of, getting those data and information into black and white concise documentation, so that it would be a base or database or information source for a decision making in future. Definitely.
Okay.
Yeah, we can, NSF can facilitate that process. Sure.
Shanta, the problem is we maintain our rainfall data by irrigation department. Then water quality data with the National Water Supply and Drainage Board. Groundwater with the Water Resource Board. So I think the requirement is to integrate all these the parameters as a central database. Even we do have as DUI in our the enterprises within zones and outside zones. We also have some of the quality parameters and data with us. So NSF can have some sort of a joint database initially, and then that can be upgraded annually so that everyone can use it for future researchers.
I think Ms. Telina, my staff officer, still hang on online. I request Ms. Telina to take these key recommendations and surface here discussion phase. Please, Telina, take note on this so that NSF could jointly with NSFC can take follow-up actions. It's also very important now, data in a discrete manner as correctly highlighted, but for as a decision-making, decision support system, it should be all the data in a holistic way in a centralized manner as a central, so it will create a holistic picture and decision support system. We well taken your point, and we will also work because I can't speak on behalf of the NSFC. Maybe Mr. Rong, are you in related to this recommendation? So I would like to give the
Afterwards, actually, the management level for our two foundations will have further talk about our future cooperation, especially in terms of our just mentioned initiative of our new sustainable development program. Actually, we can, based on that discussion, to further talk about this issue.
We have to be vigilant on that because NSFC Chinese counterparts also take part in the research project. So maybe data from your side, I don't know, having copyright or intellectual property value, and we creating a common system. There maybe, I don't know, we have to have separate discussion on that. I mean, data sharing policy or whatever with the NSFC and NSF. I understand public funded research findings, data, raw data should go back to the public. But since we are working together, NSFC and NSF, we have to discuss as a separate, maybe conducting separate discussion how to proceed with this.
Okay, thanks for NSFC gives the chance. I have some suggestions. We also know the project is finished, okay, but our friendship and the cooperation should continue. We should think in future plans Of course, we produce a lot of data. Just everyone mentioned that. But how to explain data and integrate with the historic data, we think we need to do more work to find a solution for CKDU issues. My suggestion is we should find the social data, a lot of social data, because for scientists here, we just produce a lot of experiment data and some natural, the data from the natural system, but very less data from the social system. Maybe we need some data from the social system, such as the patients year by year, which age and which district, such as the temperature, the precipitation, and the food changes, some sense, such as the social data, just for data. And second, I think we should encourage the exchange between the we also have two countries and some two parts, such as now our school plan to sign the MOU with the Department of Geology of the University of Pennsylvania, okay, that university. So sign a MOU, then that we can encourage the people exchange and some scientific more cooperation between, especially for the young scientists and young students. Now I think the Chinese university and some institute just encourage some talent from the international countries and international schools to come and tell to do some cooperation. I think this will enhance our friendship and the cooperation in future. That's all. Thank you.
Hi, I'm Metika here. Would like to make a point. I agree with the data sharing and the storing of data. That is very important. And of course, yeah, documentation of the research outcomes for the policy making is also important. But the implementation is not happening in Sri Lanka. That is the biggest issue we are facing. Whatever the research we do, whatever the outcomes we generate, even though we produce documents, even though we produce reports, whatever, those things are not implemented in Sri Lanka. Only thing they implement is like whatever the vote base which is needed by the which there is thinking by the politicians and ministers, whatever, that they need to be implemented. That is one big issue that we are facing. So the research that we do with a lot of effort is at a point go without any implementation or without any necessary or without any needfulness. That is one thing. And the other thing is like this project NSF-NSFC had grants granted us, and we have carried out our research with a lot of difficulties. I saw from many presentations that, and even in my case, we had a lot of struggling with the getting money from the NSF in Sri Lanka. So I think NSF in Sri Lanka need to have some strategy. If you give grants, that you need to secure the grantee some way or the other to have the money, the grants flowing continuously. Otherwise, it's very, very difficult for us to continue with these kind of grants. because when you collect the samples, if we don't store it in the proper manner, or if we cannot send it at the right time to the collaborators, the samples get, damaged, or they get bad. So even with the medical research here, we saw similar incidents. So there should be a way for the NSF in Sri Lanka to have a strategy to get the grants that are being promised by yourself. We have agreements, we have signed agreements, but the money is not flowing, right? So that I think NSF in Sri Lanka should have a thorough, thorough discussion among yourselves, among the NSF in Sri Lanka, the officials, to secure the grant money flowing continuously to complete the research. Otherwise, there are seasonal difficulties that we face. So, we can't go on sampling whenever the money is flowing. So we have to plan, and we have to plan the timing, especially when you go for water sampling. So these kind of difficulties are there. I really think NSF should have a strategy to get the grantees going clearly and continuously. Otherwise, grantees are facing a lot of difficulties. We can't keep the students. We can't, we had to actually beg the students to carry out the research, because they are doing it voluntarily, because no funding is coming out. So this should be taken seriously by the NSF, I guess.
Professor Methika, thank you very much for your feedback. In fact, NSF having the strategies to leverage the available, whatever the available budget and funding. Of course, as you know, the deleterious effect of the economic turbulence circumstances and also COVID faced some challenges beyond control of NSF. So that made NSF difficult in diverting, streamlining the funding. However, I am aware that NSF made maximum effort to divert timely funds to the projects which are progressing well. I know that I went through your research project file, and I observed that even during difficult time, our research division has made a case to divert second or third tranche of funding.
Yeah, that's true. I'm not talking about myself.
This is not the correct forum. This is an administrative issue. We will discuss in another forum inside the NSF once we return those. So of course, strategies are there. Somewhat this is beyond control NSF. Anyway, we will have some further discussion on this. So at this juncture, I would like to invite Professor Ming, kind invitation to shed light on the way forward, since we have heard the findings of the first call and we are lining up to the second call. So we are about to have the discussion on second phase back to back this meeting. So audience would like to hear from you, shedding lights on directives, way forward, your envision towards the second call, please.
Thank you very much, and thank all the suggestions and comments from our experts. NSFC, we actually, NSFC and NSF Sri Lanka, we have cooperation under the framework of Global Research Council. And next year, the topic for discussion will be science for sustainability. That's a key area NSFC now is working on. Of course, the UN SDGs has a very broad concept. It has 17 goals, and actually it involves many aspects. We need to identify what specific need we have for both countries. Actually, as funding agencies, we have also have many difficulties during the years because of the COVID, because of the political environment, and also because of the economic pressure. But anyway, we are placing ourselves at a position of service to give service to our scientists, to our researchers, to help them to better organize their international cooperation. So we always have an open channel to our researchers. And we also have a scientific group. It's composed of many leading scientists of China. Actually, we just have a meeting at the end of July, and Professor Yang also joined that meeting and also gave us many suggestions. Jointly, we have identified 5 key areas. I think Nian He had presented to our colleagues last month or in May.
Yeah. Actually, I presented to Professor Shaman during our last meeting. And actually, afterwards for our governance meeting, we will also introduce in detail. Yeah.
We already noticed that 5 areas communicated by Ms. Rowe.
Yes.
Yeah.
We have identified 5 key areas, and including the health, the well-being, and the resources, energy, biodiversity, also the environmental side of the Earth system. The fundamental purpose is to help our researchers and also the local stakeholders to find a pathway to sustainable development. Science plays a key role in this process because science provides the evidence, also the solutions, support to our decision makers. That's the key concept of our Sustainable Development International Cooperation Program. And we hope to continue our collaboration with NSF Sri Lanka under this broad framework.
Thank you. Of course, we can continue with any further questions, clarifications from our on-board researchers, and yeah, Mr. Rong, over to you to continue the Q&A session, please.
I think all the suggestions is very important for our future cooperation, and I think I'm wondering, is there any another questions? And because our actually the next meeting of our acting director general is waiting in the headquarters of NSFC for the next meeting. It's 3 p.m. sharp Beijing time. So I'm wondering, is there any further technical or questions or the suggestions, or we can have the conclusion bar? Yeah, thank you.
Small comment on this Professor Samin presentation. You were talking about these nanofiltration systems that can be implemented in community water supply schemes and wherever possible. So then if you can do some economic study in detail, how can we market it among the local community, and then how we can replicate systems to start some business model. Maybe we can use some entrepreneurs, and BUI also might be in a position to help for that and come up with some sort of financial models with market segments internally and externally. Then I think that would be much more beneficial for us, using our raw materials as well as part of the raw materials that we can import.
Yeah, I have another simple question. Actually, I'm not deeply expert in this field, but this I ask this as a public of Sri Lanka because in Anuradhapura, Polonnaru, Deyathakandya, there are so many BOI enterprises and so many workers belong to BOI companies. So have you found effectiveness? I mean, number of cases reported as a CKD diseases minimize after application of those apparatus, RO plants and somewhere. So, Professor Shamin, I would like to know about the summary and findings of the reduction of number of cases reported as CKD diseases after installation of that RO plants. Yeah, that is done by the health inspection and nation what they have. It's not, I mean, this moment with the supply drinking water, like expanding this network can supply more and more drinking water. With the clean water, the progressive is low. I mean, water is decreasing this. The kind of prevalence is not there. So, as a solution, the drinking water supply has been effective and it has shown a positive impact in the community.
Mr. Chintak, I think supplying drinking water in a way eventually expanding, and I think to answer to the question maybe too early, because it should be in a systematic approach with the control measures, with a systematic research only, we could be able to find the, I mean, a real impact, I mean, scientific evidence based, whether this supply has been having a significant impact or the factor in reducing prevalence. I think maybe as a NSF funding, or we may need to conduct a systematic research in those areas to find, I mean, evidence-based answer to your question. Maybe too early, but in future, definitely.
I would also like to make a comment regarding the data sharing database. So it is a very good idea, and also if the research team can propose their research gaps. So in order not to repeat the same research in the same research among other research groups, so it is much better if the research groups identify the research gaps along together with their database sharing. So the future researchers can then go by the research gaps and find their research proposals in order not to, that means not kind of wasting the money by doing the same research. So my idea is to propose, if the researchers can propose their research gaps while doing their research, it will be also much benefited to incorporate to the database. So, yes.
Yeah, thank you. I think Ms. Tilina is taking notes on your valuable comments, and we will have follow-ups on these recommendations and suggestions. I think now almost 3 p.m. Mr. Rong, it is now time to move on to the next item of the agenda, since we are also the very important meeting lineup. So better moving on to the next item, please.
I think for the overall summary, and there's the one agenda for the head of the research division of NSF engineering. I don't know if I can pronounce it right. Yes, it's Nayaka. So could you please give a brief overall summary of the project, please? Yes, I think it's your colleague, Dr. Sari for the next session. Yes. So I think actually during the discussion, we have during the Q&A session, the discussion, we have the brief summary of the project. So shall I suggest that we go to the conclusion remarks? So please, Dr. Oh, yes, please. Yes. Yeah.
Thank you very much. Good afternoon, all. Myself, Mahek Disanayake, Head Research and National Science Foundation of Sri Lanka. I think today is a very important day for National Science Foundation because we witnessed the successful completion of first joint research program between National Science Foundation Sri Lanka and National Natural Science Foundation of China, because this is a very big step for NSF. We jointly collaborate with National Natural Science Foundation of China, because NSF could facilitate, support our scientists, work with their global scientists in China, because we witnessed that China has gained tremendous technology development in their all fields following this. So in this bilateral technical cooperation, I would like to just to express briefly about what NSF Sri Lanka, because we know that one NSF Sri Lanka is a government institute under Ministry of Education, and we are currently having some funding constraints due to current economic crisis in the country. So as we started 50 years before as a National Research Council of Sri Lanka, and then we turned into National Science Foundation in 1998. So we celebrate 55 years. And our vision and mission, we always try to promote science, technology, and innovation in the country. So we try to develop research and development ecosystem in the country. Right. So, and we always try to follow two major strategies. One is support research and development innovation, and other thing is that popularization of science and promoting science education in the country. So we have key programs to support our research ecosystem or support our researchers. So those are as a grant scheme and also capacity building grant scheme, and also motivation or recognition of their achievement award scheme. So all these programs are aligned to the support our researchers. And also we followed the very transparent mechanism to review all our proposals and award the grants. And also we try to have more international collaboration or international partnership as a strategy to give our scientists to more exposure to the international exposure. So when we come to the today's contest, so we have awarded 4 grants under this first joint call. All grants are more related to the CKU, that is a major problem in our country, especially in the North Central Province and some part of other So we have 2 main objectives. One thing is that we want to develop strengthen the bilateral cooperation between Sri Lanka and China. One, and other thing is that just to find some solution to the our major problem in the country. And also in this program, we mainly focus on that networking and then fostering talent and also joint research. I think we have achieved some extent this concept, because you can see that one. We have 2 parts in our grant scheme. First part is joint research part component, and the second component is networking and talent fostering. Unfortunately, we could not allocate all the allocated funding to our researchers, but we have allocated maximum possible funds to all the researchers, and they have maximum utilized their funds. And if you come to the physical progress, we can see that one because from capacity building side, we have up to now we have produced 6 MPhils, 1 PhD, and 15 scientists work in this area, and 24 RAs as a student, technical assistant, and field assistants work in this area. So they have gained some good knowledge working in this one. So those are some talent fostering. And also infrastructure development side, we have given 4 equipment under this grant scheme, and also knowledge creation and dissemination. We have already up to now we have published 36 journal papers, 3 book chapters, and 1 patent. So I think we have created good knowledge, and also some extent we have networking, and also we support improve the talents of our researchers. And we have seen that lot of key achievement in this program, and we believe that one we can take those findings and support our community through those key findings. And as we discussed earlier, we try to convey all these key findings to the respective stakeholders, especially the Ministry of Health, and we try to implement whatever the possible findings. Because Sri Lanka also invests nearly 69 million Sri Lanka rupees to this project. And we have seen that some of the activities under this project, so we have to curtail those one due to COVID-19 outbreak, and also due to economic recession prevail in the country during that one. But even though we have seen that almost all our researchers, they have done a very good job, and they have come up with a very good achievements, except one project. And I want to thank on behalf of NSF Sri Lanka, all the researchers from both countries, Professor Methika, Professor Hyun Min Gu, Professor Rowana Chandrajit, Professor Sling Lee, Professor Shamin Dinadasa, Professor Yang Sway, Professor Rasika Pereira, and Professor Swanging Wang. So all the researchers, you have done a very good job, and your dedication and your commitment. We say thank you very much for that one. From the point of grant administration and management, actually all the Sri Lankan researchers, they have given good cooperation to us. They have always communicate with us. We know we had some problems, but they always communicate with us, and we always try to give our fullest support to our researchers, because NSF Sri Lanka always try to develop research ecosystem in the country, because we know that one, if we develop research ecosystem in the country, then only we can get science and technology and innovation result to the development of economic and social development of the country. So thank you very much.
Thank you very much, Dr. Disseminating. Thank you very much for your introduction about the NSF, and we learned about from it. And also, we also thank you for all your summary about the lesson learned of the 4 projects, and I think it's very good summary, and we can learn a lot from to better prepare our next cooperation. And for the last session, and Dr. Siri will do the summary and to the closing remarks on behalf of our 2 foundations. Dr. Siri, please.
Thank you, Ms. Ron. To save the time, I will keep it very short. I think today's meeting, I witnessed the 100% achieving the objectives, and also by hearing to all the presentations from both the counterparts, it highlight key findings, very important recommendations and way forward findings. I understand some of the key findings will make a paradigm shift or another direction to towards a new era of the prevention, in terms of prevention of the CKDU. In a way, it is amazing to see that some research findings have emanated 15 SCI publications with even patents. I observe, apart from the implementation level, knowledge mobilization and dissemination part, I see a potential for some research output for product development and commercialization, ultimately for benefit of the society, especially activated carbon nano material based nano filter may be one good potential as a product development, because Sri Lanka produce more high quality coconut charcoal based activated carbon, which could be one raw material available for future nano filter. It will be a good investment opportunity for industrial park here in China. So it indicates, of course, product development sector as well. And prevention is better than cure. I see many of the findings will emanate, will help in preventing. At the moment, Sri Lanka, the only solution is the dialysis as a solution, but especially the findings of the 4th project, it directs some patient management, of course, clinical, that kind of indication to manage with the CKDU, some key findings. So therefore, my humble request is to Sri Lankan side and Chinese side co-PIs to send their PowerPoint presentations for further processing and information compilation. And thank you very much for NSFC management and NSF management, as well as all the research team members for excellent research work and coordination and cooperation extended. And here I declare the conclusion of the event of the research sharing and finding sharing session. Thank you very much. meeting will be at the next premises, NSFC.
Yes,
premises. So we
actually,
have
it's,
more-
our headquarters very close and
Yeah.
maybe take 3 to 4 minutes walk. Yeah.
Some are waiting in the outside, so we have to rush, yeah.